one you want to do the most? That's what I got. Okay, so we're going to do number 5. We need to state the asymptotes for this function. Before we do anything else, this is written kind of weird, so you could rewrite it. Your vertical shift is in front, and you can just rewrite it so it looks more like normal. And then you also need to remember your original asymptotes. So if you don't, I can go back to your table. Remember your x's were the same as sines, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And your y's were almost the same as sine, except it had an asymptote everywhere where sine was 0. If we change our x's at all, it will change our asymptotes. Do we have any horizontal transformations? No. So that means these are our asymptotes, and then of course they would keep going. So that would be all of our pi's. So x equals pi k. Or your multiples of pi. Questions on that? Make sure you have that written down and pass it your answer sheets. Take out your notes if you haven't done that already. Okay. Last class we went over how to go from half or double angle to half angle. And then we started off by doing one of these problems. We found where this angle lies to give us whether the equation would be negative or positive. Then we found that this is some half angle, so we had to multiply it to find where it actually is on the unit circle. And that would tell us sine and cosine value. And then we started doing each of tangents' half angle formulas. The first one gave us this answer. I think we started the second one. The second one gave us this final answer. I had to go back and fix it because I multiplied something or done something wrong. But with that one, it didn't matter whether the equation was positive or negative. We just needed to put sine and cosine in, simplify all the way as much as we could. I will say if you did it the other way, you'll get something very similar to this, except I think you'll end up with a 2 instead of a 1. But it would be the same thing. No, you won't have to do all 3. Pick one, whichever one you want to do that. Now let's go back and do some others. So 75, that's not something on your unit circle. So that's some half angle. Where would that angle lie? Quadrant 1. So that means cosine's equation is going to be positive. Now it may get to a point that you may not need to do that. But for me, it helps me see what's positive, what's negative, because there's so many rules for half angle. If we multiply this by 2, what angle would it be on the unit circle? 150, which is now in which quadrant? In the second, which tells us what about cosine's value? Cosine's negative. So you'll need to know whether the equation itself is positive or negative and whether the value itself is positive or negative. Okay. What is the cosine of 150? Negative root 3 over 2. And now we use that in our cosine half angle formula. That's on your paper, so I'm not going to rewrite it. I am going to point to it though. So we know our equation is positive, so the plus or minus on the outside, we know it's positive. We don't really need to write plus all the way through. And that equation is 1 plus cosine's value all over 2. So we need to combine our fractions, get fractions with that. We have fractions within fractions, so simplify that. So once you get everything in that, everything else is just simplifying. So getting like fractions, that'd be 2 minus root 3 all over 2, all over 2. I can condense this by multiplying by the reciprocal. So 2 minus root 3 all over 4. The very last step in simplifying this is separating your numerator and denominator, because you can take the square root of both. But when you do that, you end up with this in your numerator. Leave that as is. The square root of 4 is 2. So your final answers for sine and cosine, at least, bless you, should be over 2, not over 4. What questions do we have on that?
So the square root under the square root,
we just leave it like that. It looks ugly, and we want to do something about it, but we're just going to leave it like that.
How do you determine if the formula is negative or positive?
So that determines from these types, that's dependent on this angle right here. If that angle would make, or is in a quadrant that would make it positive or negative, that determines the sign of the equation. The actual value on the unit circle for these would determine if cosine's value is positive or negative.
Also, why did you first multiply it by 2? Like, how did you get the 2?
So we have to know to do that because it's a half angle. We're going to do one more of these types and then move on to one of the other types. So now we are dealing with sine. 5 pi over 12 is not something you may know where that is. I think I converted this to, I didn't do that here. Yeah.
Is that so the tellers we're trying to find half angle, or should we just know them?
Depending on what it looks like, we should know. Now, if it gives you this, this also looks like some indifference, so there'll be a distinction between those two. If if it wants some indifference for that type, it'll say that. But the other ones you should know. I'm gonna say that when I first figured out what this is, I actually did 5/12 to figure out what that decimal would be. I don't recall what that is right now, but whatever the decimal was, put it in the first quadrant. Because think of all of your fractions as pi/6 is really 1/6, pi/2 is really 1/2, so all of those decimals would be in the first. So this was still in the first, which would mean sine's equation is positive. It is still a half angle, so we can still multiply it by 2. When you do this, you should get something that simplifies to something on the unit circle. Five pi/6 is in which quadrant? The second. So sine's value will be positive. And what is the sign of pi/6? 1/2. Because this will be a no calculator section, if you were to get something like that, what I would do is multiply it by 2 first, see which quadrant that's in, and then, so if this was in quadrant 2, half of that it would have to be in quadrant 1, by default. If it was in quadrant 3, half of that is like 1.5, so quadrant 2, and so on and so forth. So our equation is positive. I'm sorry, we found sine's value, but we need to find cosines. If you look back at the sine equation, we don't need sine, we need cosine. So that was wrong of me to say what's cosine, what's sine value. So that changes things a little bit. Now you could still write down sines, but you don't need it. You would still need to find cosines. Oh, it's my bad. The only one you need sine's value for, or may need it for, is for tangent, if you're using one of the others. Sine's half angle equation is 1 minus. Please be careful with these two, because one is 1 minus, one is 1 plus. They're not the same. But when we solve this, the answer is going to look very similar to what we got in 30. Except now I'll have a plus instead of a minus. I still need to get common denominators, combine these fractions, and simplify these fractions. Now, once you see that the patterns are kind of the same, you can skip some of these steps. So if you know that this would become this, that's fine. Or if you know that this would become this over 4, you could skip that intermediate step. But just be careful because sometimes skipping steps makes you mess up. So that would be multiplying by the reciprocal of the denominator. And then that final step, taking the square root of your numerator and your denominator. So almost identical to number 30, except one's minus, one's plus. Do we have questions on this process so far? Yeah.
If you were to define the two hyperbola, can you do that? Just break them into two.
So in order to do that, you would need to have this.
Would you accept that as an answer?
That's going to give you more simplification than you want to. You could still do that. But I want it to be as simplified as possible. This is not really, because you can still combine the fractions. You could definitely start it off that way, but then you would end up combining the fractions again. So you're just doing extra work. So 32 is going to be similar to these. We're going to do one of the others. With these types, you know that they're half angle because it'll say find some trig function with theta over 2. Theta over 2 is your half angle. With these, they also kind of look like your double angle. So because they look like that, some of the same things we did to find our double angle is going to apply. But what we knew about how to find which ones were positive and negative have now changed. Right now, they're telling us where this is. This is in the third, tangent's positive, that makes sense. So that means tangent's value is positive. That's what they're telling us first. And that's kind of a given. They show you whether it's positive or negative. That means you have to find where would your half angle lie, and that would determine whether your equation would be positive or negative. To do that, you're going to take the original domain, I guess, divide both of those by 2. Really, you're dividing each piece by 2. To find some new domain. So now you have pi over 2, theta over 2, and 3 pi over 4. It changed it completely. This is where your half angle lies. Where does your half angle lie? In quadrant 2. So that means if we're using the first half angle formula, the one that has plus or minus with your square root, our equation would be negative because it's in the second. So they've switched the value in equation piece that we knew before. Once you have those two things, everything else is the same. Almost the same. For tangent, I need to find cosine or cosine and sine, depending on which equation you're using. I should have also wrote this too. So because we're using tangent and I don't need tangent's value, I also need to know that cosine sine's value is negative. Tangent in general, whether it's this one or the other one, is just more complex. We can find sine and cosine's value by doing what we did when we were looking for our double angles. We know that this is y over x and we can find r. So we have to go back and do that. So this would be 1 plus 9 or 10. So r would be square root of 10. Remember, your r can't be negative. It's in the third. The sine and cosine are both negative, so it doesn't matter. They both need to be negative. And you're going to end up rationalizing. So for sine, we have 1 over root 10. You have to magically make it negative because it's in the third. And rationalize. And then for cosine, x is 3, so that'd be 3 over 10. But again, magically make it negative. And rationalize. Now I can do both ways, but I'll ask, which tangent half angle formula do you want to use? The third, the sine over 1 plus cosine? Okay.
Wait, well, why are we solving for tangent? Like, because it's asking to find sine.
Thank you for catching that. I was just so caught up in tangent, so we shouldn't be doing tangent at all. You're right. So that means we didn't need to find sine, we only needed to find cosine. Thank you for catching that. So pay attention to that also, because we would have solved the wrong one by accident. But here, we just need sines, not tangents. There is only one equation for sine. Let's change this a little bit. Here, when we were talking about tangents equation, we need to go back and change that to sine. And now that we actually, or I know what we're actually solving, we can actually solve for sine. We know our equation is positive, our value is negative, cosine's value. We don't need to include the plus on the outside. I just need this piece right here. So 1 minus negative 3 root 10 over 10 over 2. And we need to simplify it. Now, we rationalize this. I will say that you could wait to rationalize it until you start simplifying it. You might get a slightly different answer, but it will still work out. I'm not going to do that right now. Also, my next. Are you alright?
I checked them out. I'm good with that.
As you say, if you need to step aside. Alright, so this process is the same. Simplify, combine your fractions, get common denominators, combine everything. In this case, you're going to have this radical in with this. That's okay for now. If at some point you got something that could simplify, so let's say you got 10 plus 2 or 10 over 10, you could simplify all of those even numbers. In this case, you can't. I didn't mean to put 40. I meant to put 20. I don't know why I made that square root so big also. So if I multiplied the reciprocals, I'd be multiplying by 1/2. Just so you know where that came from. Did I simplify that all the way? Just as we did before, I do want you to simplify your denominator, but you don't need to rationalize it. Just because that would become very complex very fast. So you end up with the square root of 20. The square root of 20 simplified is what? Sorry. 2 root 5. And I wouldn't want you to go further. Yes. Yes. It doesn't look like it's supposed to be right, but I just want you to trust me. I'm trying to save you headache from trying to simplify it more. I know that I probably didn't help that I didn't start solving it right, so my bad about that. But do we have questions? I'm going to take a break from talking, and I'm going to let you guys try these. So I want you to go back and try 32. See if you can try 34, 35. If you have questions, please ask.
Darling, give me sugar, gonna show you what it feels like. Maybe it's the way you move, not noticing, just stuck up in the groove. Oh baby, surely it's the way you shine. You got silly fools stuck up in the line for you. Waiting around and wondering. Coming
want to feel you, don't want you on my mind. Don't want to feel you, don't want you on my mind. Don't want to feel you, don't want you on my mind, on my mind, on my mind, 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 mind. Why on earth would I leave if you were everything I wanted you to be? When I saw what you did, who you were with, got me questioning the things that I believe. So I ask myself, do I let you go? Do I keep you in the frame of my mind? Now I'm growing wise to your sugar-coated lies. Nothing sweet about my misery. I finally found what went wrong. I finally found the wrong in you. I finally found what went wrong. I finally found the wrong in you. Don't want to feel you, don't want you on my mind. Don't want to feel you, don't want you on my mind. Don't want to feel you, don't want you on my mind, on my mind, on my mind, 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 mind. You again, why'd you call? I don't need to hear you crying out my name. Unlike before, when you and I lay eye to eye, now it's time for you to taste the bitter end. So I ask myself, do I let you go? Do I keep you in the frame of my mind? Now I'm growing wise to your sugar-coated lies. Nothing sweet about my misery. I finally found what went wrong. I finally found the wrong in you. I finally found what went wrong. Well, I finally found the wrong in you. Don't want to feel you, don't want you on my mind. Don't want to feel you, don't want you on my mind. Don't want to feel you, don't want you on my mind, on my mind, on my mind, 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 mind.
I was told the true definition of a man was to never cry, work till you're tired, got to provide, always be the rock for my fam, protect them by all means, and give you the things that you need, baby. Our relationship is suffering, trying to give you what I never had. You say I don't know how to love you, babe. Well, I say show me the way. I keep my feelings deep inside, I shadow them with my pride. I'm trying desperately, baby, just work with me.
Do we have questions on 32? What's the next one? 32. Questions on 34? Yes. Okay. On another page. So since we're looking for cosine, equation was positive, and cosine's value is 3/5.
start simplifying. So I got common denominators first. I will rewrite my square root here. Combine those. Simplified this entire thing so I didn't have fractions within fractions. Simplify that. Remember, your last step is to take the square root of both your numerator and your denominator. And then rationalize. So when you don't have square roots, you end up simplifying a little bit more. Yeah.
If you don't rationalize it, at that step, so if you look at us 2 over square root of 5, is that like wrong?
Yes. You would need to rationalize this at that step because you can. It's not multiplying by conjugates super hard. So at that step, yes, you should.
I just took the simplify on
The last one was negative 2/3. Questions on that one? I will say I did each way and got the same thing for each one, for this one. Sometimes that happens, sometimes it doesn't. Alright, so we have finally finished 5.4. So that is your trig identities, knowing them, being able to use them, evaluate with them. What I want you to do, because one, I should have done this last time I saw you. I have 2 different homeworks. You don't need to choose both. One is on half angle, one is on double angle. I want you to choose one of them and do that for homework. I'll still put up the answers to both. They are both up here. You can choose which one you want. One says half angle, one says double angle. You can choose.